I wasn't so overly concerned that that you guys had to absolutely ace it. Okay. Traditionally, that section has been one of the more difficult ones we do all here because the whole idea of the number sense stuff and trying to go back and forth and figuring all that out, and it's okay. It really is. Yes, ma'am. Not regularly. What I usually focus upon is, can you give me the next terms of the sequence? And then I'll ask you to write the rules when it comes down to stuff that actually makes sense for rules. And that's kind of how I usually go with this stuff. So it worked out great because I knew the day I was going to be gone. So if I gave you the idea of it to start with and you kind of worked your way kind of through it for the second day, just kind of hang out, fine. Whatever. It was one of those perfect stretch the day. Why are you shaking your head in disdain, Nelson? Good. I'm glad I annoyed you. Error 5. Yes. Anyway, arithmetic. Arithmetic sequence is going to be a sequence, oops, that has a common difference between them. Difference between the numbers in sequence. Hi. Oh, wait. Who is that? Was that Seb's room? Oh, they can watch our class if they want. Seb's not here. He got bit by a dog really bad. His face is all disfigured. No, he's fine. He's just not here. That was a joke. He's fine. He's not dead. He's not bleeding profusely. Arithmetic or it's pronounced because I don't think it's arithmetic. Anyway, so what happens here is that between numbers within a sequence, the same thing is happening. For example, if I look at like -3, 1, 5, 9, 13, blah, 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 blah. Exactly. There's a common change, a common difference that's either being added or subtracted to each one of the values. Okay? And what we do is we write this in terms of an nth rule still. And the rule for an arithmetic sequence, it's going to have the exact same generic terms for it. We're always going to talk about having the first term, and then what we do is we add to it n minus 1 times the common difference. And if you notice, this winds up putting us into some format of basically slope-intercept form. Okay? Because when you're talking about an arithmetic sequence, you're talking about something that is moving linearly, if that makes any sense. Probably not. So if I want to write this one out, my first term would be -3. My common difference is 4. So my first term, -3, common difference is 4. So my nth rule would be -3 plus n minus 1 times 4. Distribute, combine like terms, and you get an equation. -3 plus 4n minus 4, which is 4n minus 7. And again, you go back to the idea that in this instance, you will now have basically slope-intercept. Okay. When you have a common difference between your terms with this arithmetic stuff, it's basically a linear function. Sir! You figured out the pattern. It went from -3, 1, 5, 9, so every time it's going up by 4. Because the other ones could have been, yeah, you know how the other ones were multiplying by like -1 to the n minus 1 times n. That's how you multiply signs. It's not arithmetic. It's not it's not a consistent growth. It's not geometric, which is a common rate multiplier. It's exponential. Those are just patterns. All right. Not too terrible. Again, what you can do is put this value, put this in your calculator, and verify that you got the right equation. It's kind of nice to be able to have that y equals button. Should I take the calculators from you? I don't know. I just feel like scaring you. All right. What about this one? What's that? What's my common difference? There isn't one, is there? This one would not be arithmetic because there's no common difference. It's plus 3, plus 5, plus 7, plus 9. What would the next one be? The difference is here, you could figure out the pattern, but it's not arithmetic because it's not increasing at a common rate. Okay? This is not considered arithmetic, so you can't do this. So your answer would be no. Bless you. Well, it's definable, but you can't. The answer is no. All right. So let's write the rule for this, and then I would like you to tell me what the 20th term in the sequence is. Take a second. Yes. That is one thing you can assume from these things is that the first term in the sequence is the first term. That is your, that would be your first term. So remember, a sub n first term plus n minus 1 times your difference. I would recommend every time you have a new sheet of paper, I would write down this formula and another one that we write out here in a minute about series notation. La, 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 la. What do you mean?
Yesterday, I thought of it.
Well, this is how you write it in terms of the nth rule. I mean, for any one of these things as it gets into this, your formula should be the same as mine because it should generate the same values.
Yeah, it's just faster. Yeah. It's like, okay, so the difference is -6 and you plug that in, and then how much you have to get to -50. So they plus.
Yeah, you're skipping steps. That's fine. If you do that, that's fine. I'm old school. I like to just go and just be done. Yeah, no, that's perfectly fine. Yeah, I'm not going to yell at you. No, you're simplifying a step ahead of others. Fine. My brain never thought like that. My brain was very sequential. Do this, and then be happy. Yeah. You're able to generate it out. So your nth term would be 50 n minus 1 times, what was it, -6? Distribute around, you wind up with -6n plus 56 as your rule. And then what do you do to find the 20th term? You substitute in -6 times 20, and was it -64, I think? Error 5, Devin, I got it right. Thanks, Devin. The best. Well, hey, just like I said, if you look at this, if you look at that generic equation, isn't there only technically 3 things you don't know? You think about it, it's just three variables, right? You've got your a sub n, first term, common difference. Because this value of n is always going to be that same value there. So as you start piecemealing together, you could be given two of them, find the third. Just like most other equations you've ever dealt with in algebra or geometry, volume of a cylinder, 2 pi r squared times the height. You can be given the volume, figure out the height, things like that. So same basic principle where you just backwards off stuff, which means we can write the rule. If the 13th term is 30, the common difference is 3 halves. How do you write the rule? Remember, if the 13th term is 30, the common difference is 3 halves. How do we write out the rule? What's the equation that generated that? So, Nina, you know how the stuff you're looking at from the SAT where you had your ordered pairs of, like, in this case, be 13 comma 30. What would be the value that generates, what would f of, what would that be? F of 30 equals something. We're trying to figure out what that value generated. All that same kind of terminology by flip-flopping x's and y's by direct substitution. So I don't know if they do this on the SAT, but it's the same principle when you had that question earlier in Flex. Does that kind of see how I'm relating that to that? So as you go through this, you know that the 13th term, so what's playing the role of n in this case? 13. So everywhere I see an n in the equation, where do I put? 13. So I know that that has to equal 30. I don't know what my first term is, but I know that the 13 minus 1 times 3 halves will help me get it. It's real tough. Ready? 13 subtract 1. I think you're right. It is 12. Yes. So 3 halves of 12. Let's see here. That means it's 12 divided by 2, which is, multiply that by 3, you get 18. So 30 equals something plus 18. Oh, back to normal, man. Yay! You can do it. What do you get for your first term? 12. There's your first term. There's your common difference. And just throw it in. So you wind up with nth rule, first term, n minus 1 times 3 halves. Move this up just a bit here. Can I go up? I don't want to get too far ahead of you guys here. I think it was terrible. Just get on the safe side. What's that? Well, I screwed up every once in a while, but that's, that's what happens. When I want us to take 12 subtract 3 halves, I should probably write 12 in terms of halves. So 12 in terms of halves would be 24 halves. So what's 24 halves subtract 3 halves? 21 halves. So your answer would be 3 halves n plus 21 halves. And there's your rule. Now again, when I do this stuff, I would take 2 seconds out of my busy day, and I would use my y equals button on my calculator just to make sure I didn't done goof. No, because I got the same answer last time. I hopefully didn't get 2 answers wrong, but I do know that 3 rights make a left. Right, Nelson? You all right? Yeah, you like. No, this is fine. I don't like your idea. I'm sorry. All right, which means one last one then. We're going to do that one. Hey, what happens if you're given just 2 values? Write out the equation. If you're given 2 terms in the sequence. If I'm given two terms in the sequence, if I know that the sixth term is 10, and my 21st term is 55, that actually allows me to just figure out the common difference. It allows me to figure out the first term as well. Because if you think about it, if I substitute in the value of knowing that the sixth term is 10, that means that the value of n is equal to what? If the sixth term is 10, my value of n is, it'd be 6, okay? So I can say the sixth term is the first term plus 6 minus 1. Well, the sixth term is what? 10. Okay? I can also do that in terms of the 21st term. The 21st term is 55, which means 21 minus 1. How are you going to solve for two variables with one equation? You can. Can you figure it out how? How?
So the difference between the two is 45.
Uh-huh.
And then the difference between 21 and 6 is 15. And 45 is 13.
Therein lies the shortcut. I'll show this both ways. What Abby just figured out, remember how I said these are arithmetic? Arithmetic generates, basically what happens is slope-intercept form. If you have slope-intercept form, that means every point is going to lie on the same line, isn't it? These are going to be ordered pairs. X is 6, Y is 10. X is 21, Y is 55. The value of X generates the Y. The value of X generates the Y. So as you go through, technically what you're finding here, long form, is the slope. D, the common difference, is the slope of these lines. Now, by doing it this way, and if you didn't catch on to that shortcut, I'll show you both ways here. What I'm doing here is I'm creating a system of equations. This becomes 10 equals a sub 1 plus 5d. The other one becomes 55 equals a sub 1 plus 20d. What I can do here is I can use elimination to get rid of the first term, just by subtracting the first equation from the second equation. You guys remember doing that vaguely? Okay. If I do that, if I subtract all these parts out, I get 45 is 15, which gives me a common difference of 3. Now, what Abby did here real quick, she remembered that the sixth, let me rewrite this here. The sixth term is 10, and the 21st term is 55, which means substitute a value of x to generate a y, f of x. So this is your x value, that is your y value. As you substitute through, change in y over change in x. Slope. Okay? So 55 minus 10, 21 over minus 6. You get 45 over 15. Either way, it works just fine when you're talking arithmetic. There is nothing wrong with that, okay? There's nothing wrong with it. What's wrong, Jordan? Bless you. I will slow down. You are welcome. Okay? Remember, this is the value, some term in the sequence, the sixth term in the sequence, the value in the domain generated something in the range. Domain, range, x, y. Domain generates the range. Sixth term goes into the good old computer machine, spits out the y. Okay? It's a shortcut way of doing it. Otherwise, go with systems, works just fine. So what we wind up with here is we get this common difference of 3, which means I can take that value of d and I can substitute it into either equation. It doesn't matter. I should still get the same first term, hopefully. So if I take this value of 3 and I substitute here, I get 10 equals my first term plus 15. What's my first term? -5. So my equation that generates this whole thing would be a sub n equals 3d minus 5. Nice work picking up on that one. First hour didn't catch that. They didn't catch it. They didn't catch it. I was waiting to see if somebody was going to catch it. No one caught it, and I went through it. Yes, ma'am. Oh, you did? Oh, yeah. No, I went through. I was going to go long to show how it works with systems. Then that's awesome. You picked it. Nobody said anything in the first hour. Well, then they're still asleep. I'm trying to avoid Royer to see how long he keeps his arm up. Sorry, joking. Okay. Are you okay with how we got the common difference of 3? Okay. So what we did was we knew that if I take this common difference, I can substitute into here, and I'm solving for my first term then. Oh, what I did here is I substituted in 5. What's 5 times 3? So 10 equals what plus 15? Subtract 15 or I get -5. I'm solving for that first term. I'm using substitution to go back. If I did it the other one, I would do 55 equals first term plus 20 times 3. What's 20 times 3? 60. What's 55 subtract 60? And that's what I'm getting first term. Does that help? Liz? D. Oh, I'm sorry. I should have been N. I'm sorry. It should be 3N. Sorry. I was thinking that. What's that? Oh, I went to an equation. I didn't do the formula. I'm sorry, guys. I'm an idiot. I screwed up again. I'm sorry, Devin. You're right. The first term was -5. I went and wrote it as slope intercept form without even substituting. I had slope intercept on the brain. This is why I can't have nice things. I'm sorry. I'm sorry. I'm sorry. I'm going to hang my head in shame. I didn't mean to. It was really nice out, and it looks nice, and I wanted to go outside and mow my lawn. I'm joking. My lawn hasn't grown. I got one more quick thing here real quick. Series. Now, I've told you guys this earlier. We're going to have multiple formulas for this stuff. Series. Series is when we try to find the sum of a sequence. Now, it's going. What's that? Yeah. It's going. I'm not going to tell you which formula is which when we do an assessment on this stuff, but I'm going to always give you the formulas. Really, really easy way to distinguish whether or not it's going to be arithmetic sequence versus arithmetic series is because the series formula has an S in it for sum of so many of them. Seriously. You see what Becker did there? He just tried to be funny. So what happens then is that when you're talking about find the sum of so many of them. Obviously, sometimes if you only have to add up like 8 of them, it's pretty quick, just do it by hand. But if you've got to add like 37 of them, there's a formula. And what happens is you always are looking at your first term, however many you're trying to add up, and then what is that in the series, what is the nth term, okay? So what'll happen is, no matter what, we're always going to try to figure out what the equation is for the nth term, and then kind of write itself through. So let me show you. For example, these questions are usually going to have 2 parts to them. One of them is find the sum of so many terms, and then later it'll be figure out how many you have to add up to get it equal to some number. Okay. So if I'm looking at the series of 4 plus 7 plus 10 plus 13 plus 16 plus 19, yeah, plus 22, plus 25, and so on, it's going to be relatively simple to distinguish your common difference. Okay. Also, it should be relatively easy to figure out what the first term is. Very good. So when I do this stuff, I have to remember that I'm going to need to use both formulas at some point in time. So I write them both down. And go from there. I need to find 30 terms, but first of all, I'm going to figure out the rule for the nth term. So I start with my first term, which is 4, plus n minus 1. And what's the common difference in this one? Let's go up by 3, isn't it? 3. So now I write out the equation. I'm going to get 3n minus 3, so I get 3n minus 1. Are we okay with that? That's my nth rule. I was making sure you guys were paying attention. Good job. So my nth rule would be 3n plus 1. All right. I need to figure out, if I need to find the sum of the first 30 terms, I need to know what the 30th term is. So I do that now. So the 30th term would be 91, yeah. Okay. So now I have info. I need to find the sum of 30. So I need 30 of them. First term was 4. Last term is 91. So what's half of 30? So then I do 15 times 95. And you get what? 1005, I think. 1425. That's close. 1425. So if you added up 30 of those terms, peace out, Devin. Enjoy the weather. I put the homework on the internet. I hear it's on computers. But then, so see what I'm saying by writing out the rule, because you're going to need to use it anyway. Plus, the second part of the problem is where you really need to have the rule. Okay. So the second part is where things can get a little weird if we're not careful. No, I did not. So if I'm going to figure out how many do I have to add together, what this means is how many in that sequence do I have to add together to make the sum equal to 175? So what we do is we know that we're going to use the sum of some amount of them, this first term plus last term, over 2. Well, we know what the first term is. We know how many, we know what we want it to equal, and we also know the rule for the nth term. Okay, if you go back to what you know, we know that we need to figure out 175 is going to equal I don't know how many I have to add together, but I do know that my first term was 4. I know that my nth rule, my a sub n, my rule for the formula is 3 times n plus 1. And I'd have to divide all that by 2. So far, so good? Okay. Now, you guys okay that this numerator becomes 3n plus 5? I want to get rid of the divide by 2. What do I do? Multiply by 2. So if I double 175, what do I get? How about 350? See what's going to happen? You're right. No, it's n. But here's the deal. When you're adding these things together, can you add a fractional amount of numbers? Terms in a sequence. Am I going to have a one and a half term in a sequence? My values of n will always be integers. First term, second term, third term, and so on and so on. Don't you have a button on your calculator that can tell you what the answer is? Y equals. What are your y equals? Instead of doing what times what is negative 1,500 or 1,150, that adds to equal 5. Lord knows I don't want to try to factor that. But if I press that into my y equals table, won't I be able to figure out where it crosses where the axis is, where my 0 is? And do I want a positive 0 or a negative 0? I want a positive 0. Where does it cross at? All you have to do is go to your table. You don't have to factor this, guys. That's stupid. You just have to be able to derive the quadratic to be able to use the calculator. I'm not taking the calculators away from you. Okay, I'm not taking them away from you. But will that negative work? If you think about it, will that negative? Because that's how many of them do you have to add together? You're telling me that I have to add a bunch. I have to add a bunch of negative numbers in a sequence. I'm looking for a positive value of n that generates a 0. I'm looking for the positive value of n that generates the 0. Now, if you don't get a 0 that's positive, that means you screwed something up in your equation, because it has to be a positive integer, otherwise it won't work. No, it should always work. Yeah, Flo, what's up? What do you got? And that's about as worse as this stuff gets. Do those. Oh yeah, they're real quick, because now you know the shortcuts. They're really, really quick, which means you should be able to get this done in about 15 minutes. Ish. Don't mind all my 15 bookmarks. Maybe, I don't know. I think so, or close to it.